Hello friends, welcome again. Today we'll be solving a problem related to control system, and the problem is the system matrix for transfer function equals to k over s cube plus a3s square plus a2s plus a1 can be. Okay, so our state space equation is x dot of t equals to ax of t plus bu of t. Okay, so here x of t are the state variables. Okay, and for this equation or for this question, the number of state variables will be 3. Why? Because it is a third order system, and how you can see that order by seeing the highest power of the denominator. So highest power is 3, hence 3 variables are required. So let us say these variables are x1 of t, x2 of t and x3 of t. Okay, now once we define the variable, let us define the input and output. Okay, so our input is u of t, so that Laplace transform of that is u of s. Okay, and similarly y of t is the output, and the Laplace transform of that is y of s. So the transfer function is y of s over u of s. Now we have defined our uh, transfer function also. Now let us proceed. So first what we will do, you'll equate our transfer function to the transfer function given to us. Okay, so this is the transfer function which is given to us. Now we will equate it to ys over us. Okay, that's what is written here. Now what we do is we cross multiply. Okay, we just cross multiply these two. Now once you cross multiply, what you get here is this thing. Okay, y of s is into s cube plus a3s square plus a2s plus a1 equal to ku of s. Okay, this is what you get. Now what we are trying to do here is we are trying to develop a time domain system. Okay, so for developing a time domain system, again what you need to do is we need to convert this into time domain frame. Okay, so what we do is we take the by first we multiply by y of s inside the bracket, and then we take the Laplace transform. Okay, inverse Laplace transform, sorry, we take inverse Laplace transform and use the property of differentiation of Laplace transform. So here what we do is y of s will go to y of t. Okay, and sy of s will go to y dot of t, and s square y of s will go to y double dot of t. Y dot of t means differentiating it once, y double dot of t is differentiating y two times. Okay, and s cube y of s will go to y triple dot of t. Okay, so these three, uh, this will be the equation that we get at the end. Okay, now what we do is we bring in our state variables. Okay, so what we do is we define our output as x1 of t. Okay, now again what we do is we differentiate it. Okay, we differentiate and we'll keep this process until we reach the highest power. Okay, so once we differentiate it, so x1 of t also goes to x dot of x1 dot of t, and we equate it to x2 of t. Okay, to our second variable x2 of t. Similarly, again what we do is we differentiate it once more, and what we get is y double dot of t. Here x2 of t again gets differentiated as x2 dot of t. So let us say that is x3 of t. Okay, now again we'll differentiate it once more, so we get y triple dot of t. Okay, now we have reached the highest power, sorry, highest differentiation here, order of differentiation. So what we get here is y triple dot of t is equal to x3 dot of t. Now once we reach the uh, highest order of differentiation, then what we do is we put that all the values in this equation 1. Okay, and from there we try to calculate what is our x3 dot of t in terms of x1 x2 x3. Okay, so what we get is x3 dot of t is equal to minus a1 x1 of t minus a2 x2 of t and minus a3 x3 of t plus ku of t. Okay, so this is what we get. Now we have both x1 dot of t, x2 dot of t and x3 dot of t. Okay, so this is our x1 dot of t. Okay, okay, this is our x2 dot of t. Okay, and this is our x3 dot of t. So now what we can do is we can summarize that, and x1 dot of t is equal to x2 of t, x2 dot of t is equal to x3 of t, and x3 dot of t is equal to a1 x1 t minus a2 x2t minus a3 x3t minus ku of t. Okay, once we get this, now we are getting somewhere, we are getting to the form that we earlier discussed, that is x dot of t is equal to ax of t plus bu of t. Okay, all the differentiating variables are on the left hand side. Okay, and on the right hand side you can see these variables are the function of only x1 x2 x3 of t. Okay, and u of t. So what we do is we pick up each equation and correspondingly we write them okay, and what in matrix form. So what we get is like x1 dot of t is only dependent of x2 of t, so you can see 0 1 0. Okay, only x2 of t it is dependent on, and x2 dot of t, if you write, it is x3 of t, so it's only dependent on x3. Okay, similarly x3 dot of t, you can see it is dependent on x1 of t as by a factor minus a1. Okay, it's written here. Similarly minus a2, okay, for x2 of t, and minus a3 for x3 of t. Okay, and also it is dependent on the input, so it is plus, sorry, this should be plus, it is plus k of t. Okay, so what you get here is this as your state space equation, where this is x dot of t and this is a, this is x, and this is b, and this is u. Okay, so if you combine if you combine this, then you get a as this matrix, or a is, okay, 0 1 0 0 0 1 minus a1 minus a2 and minus a3. Okay, so the option B matches with it, so B is the correct option for this question. Okay, so thanks for watching.